Okay, so this is an example of a heating curve. This actual example is a heating curve of water. So, what a heating curve is, it's a graph. And it's a graph that is showing how the temperature of a substance changes as time increases. So you can see that overall, when you heat a substance, the longer you heat it, the higher the temperature. It increases overall. But there are 5 clear stages. We've got stage 1 here, where there's an increase in temperature within the first minute. We've then got stage 2 here, where temperature stays the same for 1 minute, between minute 1 and 2. Then we've got part 3, which is this increase here, from the 6th to the 11th minute. Then we've got part 4, which is from the 11th to the 24th minute, where the temperature stays the same again, and then we've got an increase. So, we can actually, for water, break this down, and for any substance, into the 3 states of matter. So first of all, this first section is where the substance is a solid. The second section is where the solid is turning into a liquid. We know that as melting. So this part here, where the temperature does not increase, is where the substance melts. The next increase is where the substance is going to be the liquid. And from 11 minutes onwards is part 4. This is where the liquid is turning into a gas, and that process is called boiling. And after it boils, it turns into a gas. And it would look something similar to this for any substance. Solid, increasing in temperature. Temperature stays stationary, that's when it melts. Temperature increases again as it's a liquid until it gets to a point. And at that point it starts to boil, boils all the way. And then for a gas, it then increases in temperature again once it turns into a gas. So, one of the points that I want to make clear is here, where it's melting. You will have heard before someone say the melting point of water is 0 degrees Celsius. So, we need to know what the melting point is. The melting point is the temperature at which a substance melts. So, in this case, the melting point is 0 degrees Celsius because water melts at 0 degrees Celsius. But other materials will melt at different temperatures. Some could be higher, some could be lower. Then, if we look at the boiling point, and we use a ruler and we trace it back all the way to the y-axis, we can see that the boiling point for water is 100 degrees. And the boiling point is the, sorry, I've missed a word, is the exact temperature at which a substance boils. I'm just going to increase this. So, one thing to realise as well. Melting takes a lot less time than boiling. So boiling takes a lot longer to happen than melting. And if we're heating this up for the whole 25 minutes, that means that boiling requires more energy than melting. It requires more energy because it takes longer. Boiling here takes 11 to 14 minutes, so 11 to 24 minutes. This is 13 minutes of heating without the temperature changing. Melting is 1 minute. So the temperature when you melt something doesn't change for 1 minute because the energy is being used to break the forces of attraction. When boiling, it takes 13 minutes of heating, which is a lot more energy, to again weaken, break apart the forces of attraction. And that shows that breaking the forces of attraction going from a liquid to a gas are harder. They require more energy than melting, which doesn't take as long and doesn't require as much energy to weaken those forces of attraction. The final point I would like to make is evaporation is a random process that happens at any temperature for a liquid. So, where would that be on this graph? Well, that would actually be here. Evaporation would start to happen as soon as the liquid is formed. As soon as the solid is melted, that liquid can start to evaporate.